Today's lesson 9, deals with fronts and thunderstorms. This will probably be a 2-day lesson because the notes are kind of long and there's a lot of information we have to share here. Um, One thing that we have to know about when we are talking about warm fronts and cold fronts is we have to know about air masses. Air masses are simply just large areas of air over land that have similar temperatures, pressures, moisture levels. A cold air mass has cold air. It's usually dry and it's usually heavier. Now, since it's dry, cold, and heavy, it's got high pressure. Warm air masses have moist air in it. There's got a lot of water vapor in it. They're a little bit more dense, um, or excuse me, less dense, and they usually are associated with low pressure. Now, when you start to think about it, when we put in our notes here, uh, definition of air mass, air over a large area of land, the differences are kind of just exactly opposite. Cold air masses have dry, heavy air. Warm air masses have moist air. Cold air masses are high pressure, warm or low pressure. Cold air is more dense, warm air is less dense. They're tightly packed together for cold air, they're far apart for warm air. Cold air masses, we've talked about before, sink to the ground, and warm air masses rise up. Now, when you start to think about all the precipitation that we have, these guys, warm and cold air masses, when they collide, clouds form. That's when weather changes. That's when we get our precipitation. In fact, most of the precipitation we get, actually, water originates from the ocean. It's just gets caught up in the clouds and gets carried over land and then gets dropped. Um, this animation right here of a cold front and a warm front, pretty interesting, pretty cool to see. You can see that the cold air comes in and it kind of wedges under the warm air and sparks off thunderstorms. I'll play that again. Cold air wedges in under that warm air. You can see little flashes of lightning in here, big thunderstorm clouds right here. That's what cold air does when it runs into warm air. Cold air, since it's more dense, it's going to be down by the earth. It's going to wedge under. It's going to push that warm air up, and that's what happens there. Now, if you want to see what happens in a warm front, it does the exact opposite. The warm air comes in, and since it's less dense, it's going to slide over the top of it. Now, when it slides over the top of it, you're going to get a little bit of rain out in front here. I'll play that again. You're going to get a little rain out here in the front of the front, and it's going to be one of those longer all-day type of rains versus big thunderstorms like in a cold front. Oops. Let's go here. So on satellite images, you can usually see on a satellite image like this right here, this part right here is a front. You can tell that it's going counterclockwise, so it's actually probably, there's a low pressure system out here too. But as you kind of look and you kind of follow, you can see fronts are these big lines on maps, lines of clouds. Now you can see here on this image, you got a warm front pushing an area of higher pressure, trying to go into that area of lower pressure, and then that lower pressure, the cold front is low pressure. So a couple things you need to add into your notes. When the front is when warm and cold air meet. Looks like a line of clouds, causes weather changes, and the names are for the new air mass that's coming in. So if a cold air mass is coming into an area, it's a cold front. If it's a warm air coming into an area, it's a warm front. That's pretty important. We saw on that, we saw in the video or the animation, what happens there is that this cold air wedges under, weighs so much so it stays down and it pushes that warm air up. So when the cold air comes in, it pushes that warm air up, and you get thunderstorms and big puffy clouds. You can tell that it's cold front because it's blue. On a weather map, it'll be blue, and these little arrows kind of show which way the air mass is moving. It's kind of pointing in that direction, so it's pushing into the warm air. With a cold air pushing into warm air, usually from behind it, you have a few little showers right underneath where it's happening. You get some real heavy rain. Out front, there's very little weather going on. Now, warm fronts do the exact opposite. They slide over the top of cold air. They're usually warmer, so they rise. If you look here, warm fronts are red with half circles on a map. And the half circles are kind of pointing in the area where it's moving in. The warm air uh, runs into the cold air. Now, what happens here is, as the warm air hits it, it goes over the top and it rains out in front of that warm front. So if you see a warm front on a weather map, there's a good chance that you're going to get some rain along the way. Now, things you put in your notes: warm fronts, warm air over cold air, rises over cold air, moves slowly, long periods of ice or rain, ground temperature is warmer when the front goes through. Cold fronts, when the cold front comes through, uh, the cold air pushes the warm air up so it gets a little bit cooler. You get a lot of rain and thunderstorms along the way. As far as what makes lightning and thunder, um, well, sorry, stationary fronts. Sometimes you'll see it where they got triangles and half circles. That just means both of them, the warm and the cold air, run into each other, but neither one has taken over control. They're equal strengths. As far as lightning and thunder, thunder is that sound of the molecules separating so quickly from the lightning heating the air. It just snaps it. However, lightning is that the electrons in the atmosphere that are becoming electrically charged, and that's your lightning. Jet stream, it's a pretty important thing. This guy, he's the guy that runs a lot of our weather. He's a river of wind way up in the atmosphere, about 5 miles up or so. It affects our weather patterns all the time. You can see, well, I think it's going to be right here on this animation, the jet stream itself. What he does is he's just a river of air, and on one side is an air mass, on the other side is an air mass, and the jet stream kind of just flows right in between. He moves our weather across our country. Without him, we're not going to get weather blowing across our country. So you get a jet stream kind of flowing right in between these two air masses. So that's it. Hopefully, I mean, like I said, this will probably take Thursday and Friday this week to get done, but hopefully you understood. So.